Welcome to the Unravel product use case demos. As part of these demo videos, you will learn how to use Unravel to effectively solve your various big data application and operations challenges. In today's demo, you will learn deep dive into a complete anatomy of a Spark application, identify areas of improvement for this application. So let's get started. For today, we are reviewing an example Spark application. Some of the goals of the Unravel Spark application page include detect and fix inefficient and failed Spark apps, resolve inefficiencies, identify bottlenecks and reasons for failures within applications, optimize resource allocation for Spark executors, detect and fix poor partitioning issues, easy JVM tuning for Spark drivers and executors. The first thing you notice as part of this application page is that Unravel tries to bring all related information associated with this application in one view. Next, take a look at the top section that highlights the key KPIs associated with this application. This is extremely helpful as it provides key summary information right away. In this case, we see that the Spark application took approximately 34 minutes, and we would definitely like to see how we can further speed it up. Next, focus on the right side panel, which covers the following. Program shows the Spark code of a general purpose Spark application or the SQL query of a Spark SQL query. Task attempts show the statistics about the task attempts that are executed as part of this current application. Slot usage shows the utilization of slots over time. Containers, vCore, memory show the use of vCores, containers, and memory over a period of time. Many times, it is easy to pinpoint bottlenecks by merely looking at these graphs. Moving on, the left side panels provide more details of this application. The navigation view illustrates the various stages associated with this application. Clicking on a stage opens the stage-specific view. The Gantt view provides the component view of this application and the dependencies. The Gantt view clearly shows the time spent by the various stages as part of the overall execution. The Gantt view is particularly helpful since it helps identify bottlenecks in your execution path. The execution graph view shows both the stage view and the RDD view associated with this app. Let's double click on a stage component view and see what is going on. The stage component view provides a lot more details for that particular stage. There are several tabs of information that Unravel provides. Let's look at a few of them. The graphs view provide information on the task attempts and the slot usage associated with this particular stage. The timeline view shows how the tasks were executed for the stage over a period of time. The timeline view is especially helpful to identify issues related to data skew. The log tabs brings in all the related logs associated with this application front. The configuration views lets you see all the associated configuration with this particular Spark application. The resource usage view provides a lot of detailed information at the container level, showing you how tasks and attempts executed on a particular container. This is very helpful to identify critical resources that cause degradation of performance of the Spark application. While it's helpful to look at various views and understand the details of what transpired in an application, Unravel goes one step further and does a lot of the analysis under the hood and help point out inefficiencies and areas for improvements. We surface these recommendations via the events panel. In this particular case, the Unravel events suggest that you can speed up your application by caching an RDD that is repeatedly used. In addition, You can increase the parallelism by leveraging more executors for this particular application. Let's review the optimized run of this application after applying the recommendation provided by Unravel. As you see, the updated Spark application ran significantly faster. More importantly, it also leveraged a lot more executors, thereby increasing the parallelism available in the cluster. In this case, the Spark application ran for 1 minute 19 seconds compared to the earlier run of 34 minutes, representing a significant speed up. In summary, we learned the following as part of this demo. Understand the details of your Spark application, identify areas of performance improvements. Thanks for your time and stay tuned for more such product videos.